Alright, so this review is for pre-calc. We have a quest coming up on Wednesday covering Chapter 3, and here are some problems to work on that will help you in preparation. So first we're going to use the one-to-one property to solve this exponential equation, and I'm going to rewrite it. It's a little small. So the exponential equation says 2 to the x minus 2 equals 1 over 32. And the idea here is we need the same base on each side. We have a 2 on this side. That's good. Can I rewrite 1 over 32 in terms of 2? Well, 32 is 2 to the 5th. So this can be written as 1 over 2 to the 5th. And then to bring something from the bottom, or the denominator, to the numerator, you make the exponent negative. There we go. And here is the same base on both sides. The one-to-one property says if I have the same bases, they go away. X minus 2 equals negative 5. Add 2. X equals negative 3. 2. Radioactive decay. Okay, so again, let's just talk about what I'm going to give you. Let Q represent a mass of radioactive radium whose half-life is 1599 years. So, half-life equals 1599 years. And then I'm going to give you the initial quantity, or the initial amount. The initial quantity is 25 grams. And I want to know this part B. Determine the quantity present after 1,000 years. After 1,000 years. That's what I want. Okay? So you have to know this formula. Q equals Q sub 0 1/2 to the T divided by T half-life power. Okay? Q is what you want to find. Q sub 0 is the initial amount, 25. 1/2 is the half-life idea. T is the time, and it's going to be 1,000 years, and T half-life is your half-life time. And you're in charge of finding what this is. Now recognize how many years you're going versus its half-life. The half-life is roughly 1,600 years. You're going 1,000 years. So you're less than one half-life. So less than half is going to go away. So 12.5 would be half. So your answer should be more than 12.5. Be careful with the parentheses. And there we go. I got 16.2. And that's grams. And that's how much is left after 1,000 years. Remember that half-life formula. 3. Here we go. Let's graph a log. Here it is. I'll write it down for you. F of x equals negative log base 6 of x plus 2. So whenever you're graphing a log, I like to think of the exponential. The exponential here would be y equals 6 to the x. It's the base. The base of the log is the base of the exponent. So this graph has 2 points, 0, 1, and 1, 6. So now if I want to graph the parent function of this log base 6 of x, then I am going to reverse x and y because these are inverse functions. 1, 0, 6, 1. So now I have 2 points that are going to go on my parent function. And over here I will graph 1, 0, and 6, 1. There is a vertical asymptote. Remember, exponentials have a horizontal asymptote. Logs have a vertical asymptote. So I am going up and to the right, and then I'm going down towards the asymptote to the left. So now what are the transformations? Well, I'll do it in orange here. The negative out in front means you have an x-axis reflection. Remember, it's a vertical reflection. It's this way. That's over the x-axis. So it's an x-axis reflection. And then the plus 2 inside is a horizontal shift to the left 2. So I will reflect first. This point stays the same. This point comes down here. The asymptote remains the same. So your log is just going up and to the left now and down and to the right. And now we will shift to the left 2. Every point. 1, 2. 1, 2. And the asymptote shifts 1, 2. Now your asymptote is here. And still, the graph goes down and to the right and up and to the left. And there is your transformed graph. Alright? Notice how the domain is changed, right? Remember that the original domain is x greater than 0. Okay? But when you have this inside, that changes the domain. X plus 2 is greater than 0, so x is greater than negative 2. And notice, look at all of your x's. They're to the right of negative 2. That asymptote really starts the domain. All right. Okay. Good. 4. We are going to expand this single logarithm, and I'll write it out. Natural log of the 4th root of x cubed times x squared plus 3. Whenever you're expanding, I like to take care of the product and quotient rules first, and then the power rule. However, I don't like this cube root, or this 4th root, so I'm going to rewrite it using a power. So this is x cubed, x squared plus 3, all inside the 4th root. So notice that I use brackets because the 4th root goes to both of these. And now you have some options, okay? This is kind of messy because this power is actually ruling over both of these quantities, this x cubed and x squared plus 3. So I'm actually going to bring the power out first. Okay? And now when I break it apart, this is multiplication, so this is product rule. This 1/4 goes to both. So when I break it apart, I'm going to put a bracket here so that I know that this 1/4 is going to go to both of these logs. When you break it up, product rule, product property, we use addition. Natural log of x cubed plus natural log of x squared plus 3. So what this means is the 1/4 is going to both logs, as it should go to both of these quantities, and I broke it up with addition because of the product rule. Notice that this sum is still together. The multiplication breaks apart into addition. Addition does not break apart into addition. Logs are not distributive. And now the last thing I must do is this 3. Put it out in front. So if I slide down, 1/4, 3, natural log of x plus the natural log of x squared plus 3. And there's a good final answer. Okay, so that's kind of tricky. But again, just make sure usually it's product rule, quotient rule, and then power rule. This one had a power over everything, so I had to take care of that first. Okay, but you notice inside, product rule, power rule. 5. Okay. Here is a condensing problem, and I'll rewrite the original problem. 1/3 log base 8 of y plus 2 log base 8 of y plus 4. That's all inside a bracket minus log base 8 of y minus 1. So what I will do is I will work inside first. Typically when I condense, I like to do the power rule first, and then I do quotient and product. But for this one, I'm going to work inside first. I will start with the power. This 2 out in front is a power. So I have 1/3 log base 8 of y plus log base 8 of y plus 4 squared. On the outside, I just rewrite. Now I'll combine using the product rule, 1/3. Now when I rewrite, I can just write it as 1/3 log base 8. And now inside is y times y plus 4 squared. And now this 1/3 power applies to everything. This is the cube root, so I'm going to write it as the cube root. Log base 8 of the cube root of y times y plus 4 squared. It's just a nice way to group them. Minus log base 8 of y minus 1. And now I have a quotient property. I'm going to combine these two logs into one. Log base 8. The numerator has a cube root of y times y plus 4 squared. And in the denominator, you just have a y minus 1. And there is this multiple log expression condensed into one log. Next, solve this exponential equation. So the original equation reads 6 times 2 to the 3x minus 1 power minus 7 equals 9. Okay? This is an exponential equation. We're going to have to use logs. So the first thing I do is try to get this thing by itself, the base and the exponent. So I'm going to add 7, 6, 2 to the 3x minus 1 equals 16. Divide by 6, 2 to the 3x minus 1 equals, and 16 divided by 6 is 2.666 repeated, so just leave it in the calculator. And now it's time to write it in log form. Log base 2. The base of the exponent is the base of the log. Base exponent, third thing goes with the log, and the exponent goes alone. So there is rewritten in log form. So this is going from exponential to log form. And now let's use change of base. You can use natural logs or log base 10. Log of 2.666 over log of 2 equals 3x minus 1. I'll use my A and S, my answer button, to get that in there. So log of the answer divided by log of 2. That is 1.415, blah, 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 equals 3x minus 1. I will add 1 to both sides. 2.415, blah, 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 equals 3x, and I will divide by 3. And when I divide by 3, I'll come over here. X is 0.805. Okay? So that is an exponential converted into a log problem. Alright, next one, number 7. I'll do it in orange, not to be confused with the green above. So here's the original problem. So we have log base 4 of x minus log base 4 of x minus 1 equals a half. So whenever you see two logs on one side, condense. This is going to be condensed using the division or quotient property. Log base 4 of x over x minus 1 equals a half. And now I must rewrite this using exponentials. The base is 4. The exponent is by itself. So that's the 1/2. That comes with the 4. And then the third thing goes over here. X over x minus 1. 4 to the 1/2 is just 2. And now to solve this, multiply both sides by x minus 1. Notice I put it in parentheses because it is a binomial. We need to distribute. 2x minus 2 equals x. I'm going to bring that right over here. I'm going to subtract 2x from both sides. Negative 2 equals negative x. Divide by negative 1. X is 2. So before I circle this, I need to check to see if it works. And all I need to make sure is that it keeps the logs positive. 2 is positive and 2 minus 1 is 1. That is positive. This is a good answer. So remember, two logs in an equation on the same side, condense. Alright, last problem here. It says I am investing $2,500 in an account with the interest rate below, and that's of course 8.5%. I will not give it to you like that, so make sure you know how to go from decimals to from percent to decimal. And it's compounded continuously. And we're going to see how long it takes for the money to, and we'll do triple. Okay. So we need to know what equation. It says continuously. That is A pert. A equals P to the RT. Your A, well, if you want your money to triple, if you take 2,500 and times it by 3, you'll get your A. This is your A, 7,500. The initial investment is your principal. E is E, R is your rate as a decimal, and T is what we're looking for. So we need to get this alone. So to do that, let's divide by 2,500. 3 equals e to the 0.085t. Should not surprise that this is a 3. Comes from that word triple. And now we go into log form. The base is e, so that is natural log. Natural log, this is the base, this is the exponent. The third thing goes with the natural log. So I'm sorry, so let me do it in order. So natural log of 3 equals, and the exponent goes all by itself. I'm going to figure out what the natural log of 3 is. Natural log of 3 is, so I'm going to go over here. Natural log of 3 is 1.098 blah blah blah. That's 0.085t, and divide by 0.085. Divide 0.085, and I get roughly 12.9 is t. So it's going to take roughly 12.9 years for this investment to triple at an interest rate of 8.5% compounded continuously. Okay, so hopefully this video helped, gives you some extra practice problems. Keep practicing on your own. Again, look at your notes. The notes are very important. If you know the notes and you know the YouTube, you should have no troubles. Thanks for watching. We'll see you on Wednesday.